This is a walkthrough of how to solve a two-step equation, and I'm going to organize it in terms of a two-column proof. And in addition to that, I'm also going to show you how to solve them by modeling it visually first. When you're doing a two-column proof, the first thing you want to start with is the given. So the first thing I'm going to write down is my given equation. 3x plus 3 is equal to -9. And the reason for this is going to be it's given. So it was told to me. It was given to me. So let me jump forward to the visual model here. So let me just minimize this a little bit better so you can see it. So you can see 3x plus 3 equals -9. Again, that is what I'm modeling here. 3x plus 3 is -9. And your goal is to isolate your x's on one side. I mean, get this by itself. So I know whatever ones I have on the same side, I'm going to get rid of these first. So I just asked myself how to get rid of 3 positives. In this case, to get rid of 3 positives, I'm going to do 3 negatives. So I'm going to make 3 negatives on this side. And you can see it's not balanced anymore. So to keep my equation balanced, if I put 3 negatives here, I got to do the same thing on the other side. So essentially what I'm doing is I'm taking away 3 on this side and on this side. So to show my work here, I'm going to rewrite the previous problem. I have 3x plus 3. I took away 3 on this side, bring down my equal sign, and I have -9. And I also took away 3 on this side. So -3 to both sides. My reason here is going to be subtraction property of equality. So I'm just abbreviating it. Subtraction property of equality. My next step is to simplify. So I take my 3 negatives. I can combine it with these. You can see it makes 3 zero pairs. So I'm left with just 3 x's here. On this side, when I combine these, there's no zero pairs. So you just end up with 3, 6, 9, 12 negatives. So I have 3x equals -12. So I can see the same thing here. When I combine 3 positives and 3 negatives, that's a zero pair. So I'm left with 3 x's. Bring down my equal sign, and -9 minus 3 is just 12 negatives. So -12. And the reason for this is called simplify. So if I just put the numbers together, I'm just simplifying because I put these together to get -12, and I put these together to cancel out to give me 0, and I'm left with 3x is -12. Don't forget, your goal is to solve for the value of 1x. I have 3 x's here. I only want 1x, so what I'm going to do next is I'm going to split these up. I'll make 3 equal groups here, and by doing that, on this side, I'm going to balance it out by doing this as well. I'm going to divide this by 3 as well. So I'm going to create 3 groups, and I can see I'm going to have to move some of these around. So I made 3 equal groups on this side and 3 equal groups on this side. So this is the division property of equality when you make equal groups on both sides. So essentially, I took my 3 x's, I divided it by 3. I took my 12 negatives, and I divided it by 3. This is called division property of equality. Division property of equality. And the division property of equality, all it allows you to do is it lets you see that each of these x's matches up with 4 negatives. So 1x is equal to -4. And you can see here, if I were to divide it, it's just going to give me 1x, and this divided by that is just -4. So I made 3 equal groups on both sides, and this lets me know the value of each, what's in each group. So one group of x's is equal to 4 negatives. This is called simplifying. All right, here's example number 2. Prove x is -4, given this equation here. So we're always going to start off with the given equation. So 3 equals x over 4 plus 4, and the reason will be given. So now we want to solve for x. So let's jump over to the model on Desmos. 3 equals x over 4 plus 4. Our goal is to isolate the variable, which in this case is on the right side of the equation. So I want to first get rid of the ones that are on the same side as my variable. So I'm going to get rid of these 4 positives. And the way I'm going to do that is I got to put 4 negatives. So basically, I got to eliminate those. So I need the opposite. So I'm going to do opposite of that. And you can see it's not balanced anymore. So I'm going to do the same thing on the other side so it balances out. So essentially, I'm taking away 4 on the right side and left side. So I go back to my problem here. I'm taking away 4 from the left side. And I also took away 4 from the right side. So -4 to both sides. And this is called subtraction property of equality. And now that I took away 4 to both sides, my next step is to simplify. So I'm just going to combine these. You can see I have exactly 4 zero pairs, which is why I subtracted 4. I want to get rid of those ones. Then I'm going to combine these over here as well. And you can see we're left with 1 negative on the left and just x over 4 on the right. So again, 3 minus 4, we're left with 1 negative. And when you combine these together, we're just left with x over 4 because these cancel out. And when I put these together and put these together, that's called simplifying. Next, we don't have a full x. Again, we're solving for x. We want 1x, but this is 1/4 of an x. So you just ask yourself how many of these you need to make one whole amount. To do that, I'm going to make 4 copies because you need 4 of them to make a whole. So I made 4 copies of this. That's going to give me 1x. Notice it's not balanced anymore. So what you do to one side, do the same thing to the other side. So I'm going to make 4 copies on this side too. And by doing that, you're going to see that it balances out. So you see now it's balanced. So essentially, I multiplied this by 4, and I multiplied this side by 4 because I made 4 copies on both sides. So I go here, I did 4 times that -1, and I did 4 times the x over 4. So I did 4 copies of that, 4 copies of that. And this is called multiplication property of equality because I multiplied both sides by 4. And then next, you'll see that these 4 combine to give me 1 whole x. So notice it's still balanced. So -4 is equal to x. So when I go back to this paper, multiply this out, you get -4. And then 4 of these together makes 1x. So -4 is equal to x. And all we did here was just simplify. We simplified because we just multiplied these together to get this and multiplied these to get that. Now in this problem, we have a step 6. Even though we solved for x, one thing I want to point out is that notice they said to prove x is -4. Right now, we just proved that -4 is equal to x. But we could already tell that these are the same thing. But the last step, what you're going to do in this case is we have to swap these. Because in a 2-column proof, you want to make sure that your final step looks exactly like your whatever you have to prove. So this was not the same because we have to swap places. And when I swap places like this, that is called the symmetric property of equality. So symmetric. So notice it sounds like symmetry because we have symmetry. So symmetric property of equality. So when you swap places, symmetric property of equality is your reasoning. All right, this is my third example. We're going to prove x is -1 given this equation here. So as usual, start off with your given. So 2x minus 4 is -6. Again, this is given to me. So now I'm going to jump over to my scale balance. You can see here, we want to isolate my 2 x's, which means I got to get rid of these 4 negatives. And you can see here, to get rid of 4 negatives, I put 4 positives, and I balance it up by putting 4 positives on this side as well. So my step 2, you can see I added 4 to the left and right side. Since I added 4 to both sides, that's the addition property of equality. Next, you're just going to combine like terms, so put the 0 pairs together. So you have 2x on the left and -2 on the right. So you can see I combined these to get 2x on the left, combine these to get -2 on the right. And that's called simplifying when you put the numbers together like that. Next, you can see that we want to solve for 1x. So in this case, you just split them up. 2 equal groups here and 2 equal groups here. So we split it up. This is division property of equality. So to show your work, when you're splitting up on both sides to 2 equal groups, you just put divided by 2, divided by 2. That's how you show that algebraically. Division property of equality is the reason. And then clearly you can see that each of the x's matches up with 1 negative. And to show that, if I delete this, you can see it's not balanced. But when I delete the other one, it balances out because each x is worth -1. So you can see here, when you divide this out, you get 1x. When you divide this out, you get -1. And by doing that, that's just called simplify. And notice we have to prove x is -1. We have x is -1, identical. So we don't have to do any swapping in this case. And then on our last example, we start off with the given, x over 3 plus 2 equals 4. Again, that's the given. So we're going to use this model to solve it. You always want to isolate your variable. So if you have ones on the same side, get rid of that first. So I'm going to get rid of those 2 negatives, or the 2 positives by putting 2 negatives. So I put 2 negatives here. You can see it's not balanced. To balance it out, I'm going to repeat on the other side. Add 2 negatives here. You can see it balances out. So -2 to both sides. So you can see here, I took away 2 from the left side and I took away 2 from the right side. That's the subtraction property of equality. Once you do that step, then you're going to actually simplify. So by combining the like terms together, I combine my like terms together and I can see I have x over 3 is equal to +2. And you can see here, when you combine this, that's gone. When you combine this, you get 2. So x over 3 equals to 2, and that's called simplifying. And remember, your goal is to solve for the value of 1x. Right now, we only have 1/3 of an x. So you just ask yourself, how many of these do you need to make a whole amount? In this case, you need 3 times that amount. So I'm going to make 3 copies of that one. And if I triple this side, I times it by 3, I got to do the same thing on this side. I'm going to triple this side as well in order to balance out the equation. And you'll see now it's balanced. So again, when I triple each side, you're multiplying by 3 on both sides. So you can see here, to show the work, I'm tripling this one and I'm tripling that one. So triple it, triple it. That's how you show the work for this. That's the multiplication property of equality, because I multiply both sides by 3. And now, remember, 3 of these together, I can swap it out with an x, because 3 of those is 1x. So 1x is equal to 6. So you can see here, 3 of these makes 1x, and 3 of these is 6 total, and that's called simplifying.